In this 2-unit course, we went through and manipulated the roots of a quadratic equation. So we want to do the same thing again. This is just a review of that work where we have two roots alpha and beta of a quadratic equation. Remember, if you remember, we got the sum of the roots, alpha plus beta, without actually finding the roots. We saw that there was a relationship between the roots and the coefficients. So we got the sum of the roots being minus b on a. So in this case, it would be minus of 1 on 2. And then the product of the roots was the c on a. So we got minus 3 over 2, and that gave us our results there. And then we start to manipulate equations, expressions to be able to get those expressions in terms of alpha and beta and alpha plus beta, and we were able to solve those problems. So alpha squared beta plus alpha beta squared, we factorized, then we put our values in and then multiplied. 1 on alpha plus 1 on beta gave us the sum of the roots over the product of the roots when we got a common denominator and solved the fraction, so we were able to solve that. We were able to do the same thing for alpha squared plus beta squared. If we see out as the same as alpha plus beta all squared minus 2 alpha beta, so we're able to substitution and get 3 1/4. Alpha minus beta all squared come out to alpha squared minus 2 alpha beta plus beta squared, so we know alpha squared plus beta squared was alpha plus beta all squared minus 2 alpha beta minus another 2 alpha beta. We can sub it in. Once we got back to alpha plus beta and alpha times beta, we were able to do our substitution. And even when we got to something like alpha squared plus beta squared, once we've already solved it, we just subbed it in. So alpha cubed plus beta cubed, we were able to do our manipulation and factorize to do our substitution. So that we could do that with the two with a quadratic. Now we can do the same sort of idea with a cubic. So the idea here would be, if we've got ax cubed plus bx squared plus x plus d, we would have 3 roots for a cubic equation. So again, we get the sum of the roots. It's minus b on a. We can call this the sum of the roots one at a time. We could also start multiplying our roots and adding them. So we alpha beta plus beta gamma plus alpha gamma. This would be the sum of the roots 2 at a time. So we take a multiplication of 2 of the roots and then sum them together. And that gives us c on a. That comes about c on a. So we can get the that result there. And alpha times beta times gamma is given to us by minus d on a. So we take the d there, which is the constant, and over a, and it's negative. So this is the sum of the roots 3 at a time, or we generally call that the product of the roots. So we have that situation for the cubic. We can also get it for a quartic equation. Now, you might start to see a bit of a pattern occurring. So a quartic equation, we have ax to the power of 4. Now remember, the only rule we have for our coefficients is that a can't be 0. That's the only rule we have, and they've got to be real, obviously. So alpha plus beta plus gamma plus delta, given to us by minus b on a. So the sum of the roots, 1 at a time. And we sometimes use this notation, sigma a, alpha. Then we can do the sum of the roots 2 at a time. So, and you can see it starts to add up when we take them 2 at a time there. But that would be c on a. So 1 at a time was given to us by the minus b on a, and then 2 at a time is c on a. We saw the same idea. Taking 2 at a time was c on a. So you might be able to see the pattern occurring. For alpha, beta, gamma, and so on, that's the sum of the roots 3 at a time. And that's given to us by minus d on a. So again, same as we did before, except it was the product of the roots with a cubic. Now the product of the roots this time is all 4 multiplied together, which is e on a, that constant over a. So sum of the roots 4 at a time, or the product of the roots. So there's the results we get. Now it's up to you to remember those. How can you come up with a pattern? It's going to allow you to remember that. That's how you do it. It's up to you, but you've got to remember it somehow and be able to use those results as you go through solve problems like this one, where you've got a cubic equation and you find the product of the roots is minus d on a. Sum of the roots 2 at a time is c on a. Sum of the roots 1 at a time is minus b on a. So you get those 3, and then again, all our expressions can be manipulated down to one of the 3. So 1 on alpha, 1 on beta, 1 on gamma. Get a common denominator, and we've got alpha, beta, beta, gamma, and alpha, gamma. And we get the sum of those, so it'll be the minus a half over the product of the roots from A, which is 1.5, and we're able to solve that. So you can see we can do the same sort of things we did with the 2-unit course, but with 3 roots or 4 roots as it may be. So again, we got brackets like this, expand it out. Expand the first one, alpha plus beta plus 1, and then multiply that by gamma plus 1, so we get that expansion. Now you can see that you get the product of the roots, you get the sum of the roots 2 at a time, and you've got the product of the roots, sum of the roots 1 at a time, and plus a 1 for good measure. And you're able to substitute in those values, and we get down to an answer there. So you can see how we can manipulate these again like we did in the 2-unit course, except we'll be able to work in this time either having 3 roots or 4 roots.